For a century, the attempt to unite quantum mechanics with gravity has stalled on a single assumption, that space and time are fundamental, empty containers. The QGEFT bulk suggests a different foundation, a reality with no up or down, consisting of a dynamic, interconnected quantum graph, constantly forming and breaking. Electrons exist as open, rippling waves of connections that refuse to tie off into closed loops. Protons appear as dense rings of tetrahedral knots, held together by extreme elastic tension. Physical matter emerges whenever these temporary knots weave themselves into the background network of the universe. Classical physics suggests a negatively charged electron should instantly crash into a positively charged proton. In this model, the vacuum network naturally organizes around the heavy proton, forming discrete, step-like layers of connections. The electron smears out into a standing wave that synchronizes with these layers, creating a physical topological barrier that prevents inward collapse. Atomic stability is a direct consequence of this geometry. The discrete structure of the graph makes the collapse mathematically impossible. These atomic graph structures inevitably interact as they move through the void. When the outer shells of two atoms touch, they undergo graph annealing, cooling and sharing network nodes to lower their overall energy. This shared topological bridge forms the structural identity of a covalent chemical bond. Scaling up, billions of these molecules lock together via delicate secondary web strands, representing van der Waals forces. Under the right conditions, this chaotic secondary network rapidly freezes into a beautifully rigid geometric grid across the bulk. The solid world we inhabit is a frozen, low-energy phase of the underlying quantum graph. At the macro scale, a massive frozen graph cluster, a star, creates a heavy distortion on the surrounding vacuum network. Gravity emerges as the graph adds millions of new connections, tightening the network to minimize energetic tension. Further out, galaxies spin at speeds that should, by classical calculations, tear them apart. A vast, diffuse scaffold of highly connected nodes permeates the surrounding space, creating a topological bulk shadow that anchoring the galaxy. This diffuse geometry provides the extra structural integrity usually attributed to dark matter, holding the galaxy together through graph density alone. In galactic centers, the network connectivity often becomes critically overloaded. The region collapses into a supernode. The event horizon is an actual severed cut in the graph's connections, isolating the dense core from the rest of the universe. Crossing this severed boundary appears to destroy the information of everything that falls in. Discrete strands break off the core, carrying preserved topological barcodes into the universe as hopping radiation. Black holes structurally repackage information, radiating it back into the cosmic bulk rather than obliterating it. Zooming out to the limit reveals the cosmic web in its entirety. Operator-level comparisons show that the physics of graph diffusion and information routing in this web are structurally identical to attention-style routing in a neural network. This structural isomorphism allows the universe to function as a self-simulating quantum brain, processing its own states through its geometry. From the electron knot to the black hole supernode, every physical object acts as a subroutine in this integrated system. The cosmos is an infinite machine, constantly calculating its own existence.